Hey Hux. So we're still trying to figure out how is energy obtained from a chemical reaction. Okay. And today's lesson we're going to talk about chemical reactions, actual reactions. Okay. So at the end of this lesson, you should be able to sort chemical equations into the five basic reaction types. Okay. So, in a chemical reaction, one or more reactants are converted into one or more products. So, in a chemical reaction, you can have just one reactant that can split apart and become something else. Um, and or you could have, two reactants that combine together. Okay. But it's one or more of reactants, one or more compounds that get together, and when they're done they turn into one or more of something else. Okay, how does that happen? Well, old bonds are broken. So like if this is our reaction, right, we're going to take two hydrogen atoms plus one oxygen atom and create two water molecules. Okay. um so there's bonds between these uh elements, right, because they're diatomic. There is bonds between there. So we need to break those bonds. So we need to add energy to break those bonds. And then when they're broken, they're all kind of, floating around. And this is like in milliseconds of time. Okay. And then all of a sudden they just kind of form new bonds, right? The particles kind of move around and they hit each other, and the next thing you know, they're now bonded together. Okay. Um, and then when you're going from your reactants to your products, your properties are going to change and the amount of energy is going to change. And that's what this bottom part shows. It shows here's my two reactants together. All of a sudden some energy comes in, and and during the reaction that energy gets pushed out, and now I have less energy because I have two molecules. Okay. There are five basic types of chemical reactions. And so if you think of the ABCD as individual compounds, right, individual atoms, it will help you understand how to tell each of the different types apart. Okay, so in a combination or synthesis type reaction, we're going to take one element and add another element, and then those are going to bond together and become something. Okay, so you have two or more elements or compounds that combine to form one compound. Okay, in a decomposition reaction, you have a compound, just one compound, and it is going to decompose or split apart into one compound plus another compound. So you have a complex molecule that breaks up into single ones, okay, into single molecules. Okay, there's the single replacement. That is where we take an element plus a compound, right? So we have an element, so an atom of some sort, plus, and then we have a compound where you have two atoms that are bonded together. And that's going to form, it's just going to take A and B are going to switch places. Okay. So A and B are going to switch places. Okay. So one element replaces another in the compound. Double replacement, similar to single replacement, except instead of starting with just a lonely little atom, you're starting with two compounds. So A and B are together. They're individual atoms that are bonded together. Plus C and D are individual atoms that are bonded together. Okay. After they mix, they have to, unbond and then come back together. And what will happen is A and C will switch places. Okay, A and C switch places. Or you could think of it as B and D switch places, either one. Okay, the description really is that the cations and the anions exchange partners. Okay, so if you think of A and B as partners, after the reaction, they've switched partners. So now A is partners with D. Okay, the last one is combustion. Combustion always has to do with an element, usually a metal, okay, but doesn't have to be a metal, but an element, and we're going to add oxygen to that element. Normally, what will happen is it will catch fire. That's why we call it combustion, okay? And so what we're going to get out of that reaction is water and carbon dioxide, okay? If there are other elements other than just A and O, then you could have plus and then, single elements over here. But we're just going to leave it right now at a single element plus an oxygen molecule, and we're going to get water, and we're going to get carbon dioxide. Okay? Okay, so here are our examples. We have sodium chloride. So if you think of it, sodium is an atom and chlorine is an atom. So you can think of this as A and B. And then we have silver nitrate. We can think of silver as an atom. It's its own atom. So that's going to be C. And then this nitrate right here, that is your D, right? It's all together as a package. Those two are going to mix together. And remember that they have to break apart and then get back together, right? And not be this with the same ones that they were before. So now I have sodium, which is an A, and nitrate, which is D, plus silver, which was C, and chlorine, which is B, and I need to know what type that is. So now if I go back to my list, my chart, I can see that same layout is the same as the double replacement. So we're going to call that a double replacement reaction. Okay. The next one, hydrogen is an element, so that's an A. And chlorine is a different element, so that's a B. And then on this side, I have hydrogen and chlorine, but they're bonded together. Okay. And then again, if I look over at my my chart, I get that is a combination. Okay. The third one, I have hydrogen and oxygen that are bonded together. So hydrogen is A and oxygen are B. And that's going to split apart and become hydrogen by itself, A, plus oxygen by itself, B. So if I go back over here, I find that this layout is the same as decomposition. Okay. So you should now be able to identify the reaction type based on the equation.